The ULSes mission to the Moon, which aimed to be the first privately funded lunar exploration mission since the 1970s, quickly captured the attention of space enthusiasts, innovators, and the general public alike. Space exploration has always been a domain dominated by national space agencies, most notably NASA, which is synonymous with the legacy of the Apollo missions. The idea that a private company could take on the incredible challenge of landing on the Moon, and potentially setting the stage for a new wave of commercial space exploration, was nothing short of groundbreaking. But what truly happened to ULSes, and how did the mission fare in what could be considered one of the most ambitious space endeavors of the modern era? The mission, dubbed ULSes, was a multifaceted endeavor that showcased the cutting-edge collaboration between both private and public entities. While NASA contributed critical technology and know-how, SpaceX provided the rocket needed for the spacecraft to break free from Earth's gravity, and a private company called Intuitive Machines was responsible for the financial backing and execution of the mission. This collaboration was a glimpse into the future of space exploration, where private companies and governmental agencies could work hand in hand to unlock the mysteries of our solar system. Despite this optimistic outlook, the mission quickly encountered several hurdles that made it clear just how difficult and unpredictable lunar exploration can be. ULSes embarked on its 6-day journey to the Moon, its destination being the Shackleton crater, located near the lunar South Pole. This area has been a point of particular interest for lunar exploration because it is thought to contain water ice, which could be an invaluable resource for future lunar settlements or missions. The existence of this water ice could potentially support human life on the Moon, making it a key component for plans of lunar colonization and long-term human presence on the lunar surface. With the ULSes mission's focus on investigating this area, the mission's goal was clear: gather data, assess the composition of the surface, and begin the groundwork for future lunar exploration. But like all ambitious missions, ULSes had to navigate the challenges of space travel and landing on an alien world, a feat that requires precision and an immense amount of technological expertise. The spacecraft successfully completed the majority of its journey to the Moon, and with each passing day, the team behind ULSes grew more hopeful about the outcome. However, the most challenging aspect of any lunar mission is the landing. Unlike Mars or other celestial bodies, the Moon's surface presents a unique set of challenges. Communication is difficult, given the distance from Earth, and the gravitational forces involved mean that even minor miscalculations can have disastrous consequences. The moment of landing is a critical one for any space mission, and even slight errors can lead to significant setbacks. For ULSes, this moment of truth arrived as the spacecraft neared the Shackleton crater. At first, everything seemed to be going smoothly. ULSes was on track for a controlled descent, its systems functioning as expected. However, just moments before the final touchdown, things took an unexpected turn. A small snag occurred during the landing process, resulting in the spacecraft tipping slightly to one side after touching the lunar surface. The team was undoubtedly on edge as they watched the landing unfold, knowing that a tilt, even a slight one, could have significant ramifications. The landing was technically successful. ULSes made it to the Moon's surface, but it was no longer in the ideal position. The spacecraft had landed nearly 30 meters from its intended site, a seemingly minor discrepancy in terms of space exploration, but one that had far-reaching consequences for the mission's goals. Interestingly, this wasn't the first lunar mission to encounter such an issue. A few months earlier, Japan's SLIM mission, which also aimed for a precise landing on the Moon, experienced a similar problem. SLIM's spacecraft had made a controlled landing only to tip over, a setback that had to be managed with ingenuity. However, unlike SLIM, which suffered no significant damage, ULSes faced more serious complications. Although the lander itself was mostly intact, the positioning created challenges for the onboard rover, IRIS, which was intended to explore the lunar surface. IRIS, which was housed within the lander, was now stuck, unable to deploy and begin its exploration of the Shackleton crater. The rover's inability to move, coupled with the less-than-ideal landing position, meant that the full potential of the mission would not be realized. Despite this setback, the team behind ULSes did not give up hope. The good news was that the lander itself was still operational. The onboard scientific instruments, such as the laser reflector, magnetometer, and camera, remained functional, allowing the mission team to still gather some data from the lunar surface. The laser reflector was particularly important because it would allow for precise measurements of the distance between Earth and the Moon, which could have valuable applications in future lunar missions, such as fuel supply planning and navigation. The magnetometer was also crucial for studying the Moon's magnetic field, which could provide insights into the Moon's geophysical structure and its evolution over time. Additionally, the camera allowed the team to capture images of the lunar surface, providing important visual data despite the rover's immobility. Although these scientific instruments remained operational, the limited mobility of the rover severely hampered the mission's ability to fully explore the Shackleton crater. IRIS was designed to perform key tasks. It would have gathered lunar soil samples, conducted geological surveys, and transmitted high-resolution images of the surrounding area. This data could have greatly enhanced humanity's understanding of the Moon's composition, its potential resources, and its suitability for future colonization efforts. Additionally, the rover was expected to measure radiation levels on the Moon's surface, an essential component in assessing the risks that future human missions would face. Unfortunately, with IRIS stuck inside the lander and unable to deploy, the scientific return from the mission was less than what was originally envisioned. Despite these challenges, ULSes should not be viewed as a complete failure. In fact, it was an extraordinary achievement in many ways. For one, it demonstrated that private companies, backed by both public and private funding, could successfully send a spacecraft to the Moon. This was the first time in history that a privately funded company had sent a lander to the lunar surface, which marks a significant milestone in the history of space exploration. The mere fact that Intuitive Machines was able to launch and land a spacecraft on the Moon is a tremendous accomplishment in itself, especially when considering the many challenges that had to be overcome. The mission also demonstrated the growing role of private companies in space exploration, a trend that is expected to continue in the coming decades as more and more companies look to capitalize on the opportunities presented by space. In many ways, the ULSes mission mirrors the mythological journey of Odysseus, the ancient Greek hero from Homer's epic poem, the Odyssey. Just as Odysseus embarked on a long and arduous journey, only to encounter unexpected obstacles and setbacks, ULSes too found itself facing challenges that were not anticipated. Yet, like the hero of the Odyssey, the ULSes mission was able to glean valuable knowledge and experience from its journey. The data collected from the mission, even if not as extensive as originally planned, still provided valuable insights into the Moon's surface and the technological capabilities of private companies to conduct lunar exploration. In this sense, the ULSes mission, like Odysseus, may not have returned home with the exact treasure it sought, but it still made significant contributions to the larger quest for lunar exploration. The Moon itself has long been a source of mystery and wonder. In many cultures, it is viewed as a symbol of duality, its light representing life, fertility, and enlightenment, while its dark side is often associated with secrets, fear, and the unknown. These dual aspects of the Moon are reflected in the experiences of those who attempt to explore its surface. The ULSes mission, for all its triumphs and setbacks, is part of this larger narrative, as space explorers continue to venture into the unknown with the hope of uncovering new knowledge and resources. Despite the challenges that ULSes faced, the fact that it reached the Moon, albeit not with the full success that was initially hoped for, demonstrates the resilience and determination of the teams behind these missions. In many ways, ULSes represents the dawn of a new era in space exploration, one in which private companies will play a central role in humanity's quest to understand the cosmos. The mission's partial success has paved the way for future ventures into space, and many more private enterprises are likely to follow in its footsteps. As companies like Intuitive Machines and SpaceX continue to develop new technologies and refine their capabilities, we can expect to see more private missions to the Moon, Mars, and beyond. These companies, unlike government agencies, often operate on tighter budgets and faster timelines, which means they are more likely to innovate and take risks in ways that could accelerate the pace of exploration. Moreover, the ULSes mission has demonstrated the importance of learning from failure. Space exploration is an inherently risky endeavor, and not every mission will be an unqualified success. But the lessons learned from missions like ULSes, whether they involve landing challenges, rover deployment issues, or technical failures, are invaluable. These experiences will inform future lunar missions, helping to refine the technology and techniques necessary to make lunar exploration more reliable and sustainable. In this sense, ULSes may be remembered not just for its setbacks but for the lessons it taught and the groundwork it laid for future exploration. Looking ahead, it is clear that the Moon will play an increasingly important role in humanity's efforts to expand beyond Earth. With its proximity to our planet, its potential resources, and its status as a stepping stone for missions to Mars and other parts of the solar system, the Moon is poised to become a key focus of space exploration. As more private companies and national space agencies turn their attention to the lunar surface, we can expect a new wave of discoveries and innovations that will shape the future of space exploration. ULSes may not have achieved all of its goals, but it was a crucial part of this exciting new era, and its partial success serves as a testament to the possibilities that lie ahead. The journey to the Moon is far from over, and the lessons learned from ULSes will be instrumental in ensuring that humanity's future on the lunar surface is successful and sustainable.